In the second stage now, we have three international experts contributing also statements from the more scientific point of view. And the first person to talk is John Warner with the Warner Babcock Institute. Now, John Warner is one of the founding fathers of green chemistry. And I met him personally during the ECC conference in Lisbon, where he got a very highly prestigious award by the German Chemical Society. And he gave a utmostly inspirational talk there, and we asked him to deliver also a brief contribution for the kickoff event here today. And I'm very happy to show now this video, and I hope it will be as inspirational for you as it was for me. So have fun.
Hi, my name is John Warner, and I'm very happy to be a part of this very important day about green chemistry in Austria. I wanted to share with you a few thoughts as you explore today's mission and the discussion about green chemistry. You know, when we think about green chemistry, you know, we hear all this bad news that this molecule is hurting us, this is toxic, this is dangerous, this is bad. We hear all of this scary stuff. It's almost like, you know, that game Whack-A-Mole where the little animal comes up and you hit it and another one comes up and you hit it and it comes faster and faster and faster and faster. Well, in the United States, what is the mascot of the American Chemical Society? It's actually a mole. It's like we're playing this game Whack-A-Mole with chemicals in society. We hear about climate change, whack. We hear about bisphenol A, whack. We hear about PFAS, whack. We hear about nanoparticles, whack. We hear about ocean plastic, whack. And here we are as chemists trying to understand these issues. Part of us is worried that this is very serious. Part of us is worried it's not very serious. But we chemists, we people who understand molecular structure, we're not quite sure. And this is an important thing to be thinking about, you know, in that let's accept that there are red dyes in commerce that cause cancer. Let's accept that there are additives in plastics that cause birth defects. Let's accept that there are monomers that are endocrine disruptors. You know, we go around saying, is this toxic? Is this dangerous? Is this bad? But there's actually a more fundamental question we should be asking. That fundamental question is, why would a chemist make a hazardous material in the first place? We assume nobody wants these things to be toxic or dangerous. So maybe what we need to be doing is not looking just at how we make molecules, but how we train chemists. Because every year, just in the United States, every year we graduate about 15,000 undergraduate degrees in chemistry, 3,000 master's degrees, and 3,000 doctoral degrees. In 2004, more women started to become chemists than men. What could be more important to the field of chemistry than understanding the relationship between molecular structure and being able to predict whether something might be toxic for humans or harm the environment? But what I realized back in the 1990s that to get a degree in chemistry, not one university in the world required a chemist to have any training or knowledge about mechanistic toxicology or predictive environmental damage of chemistry. So when we hear about the red dyes that cause cancer or the plasticizers that cause birth defects or the monomers that are endocrine disruptors, this isn't some epic battle of good and evil. This isn't evil industry and wonderful environmentalism, Darth Vader, Luke Skywalker. It's more complicated. The field of chemistry has evolved to not see this as part of who we are. And so back in the 1990s, Paul Anastas, who was working at the US EPA, and me, who was working at the company Polaroid, we realized that the world didn't need a political movement, didn't need a social movement. It needed a science. And what does a science have? Science has journals, textbooks, classes, conferences, workshops. And that is the birth of the field of green chemistry. We started in the early 90s. We wrote this book that got published in 1998, in which which we define green chemistry as the utilization of a set of principles that reduce or eliminate the use or generation of hazardous substances in the design, manufacture, and application of chemical products. The point here is that green chemistry is about inventing technologies that don't cause these problems. It's not about cleaning it up and remediating and recycling. It's about designing new chemistry that is just better. And so the 12 principles of green chemistry are principles that in the lab inventing new technology, they can use the 12 principles of green chemistry to help them invent. But that's the most important component here is that green chemistry has to succeed in the real world. So yes, the technology has to be more environmentally benign than alternative technologies, but that's not enough. The technology actually has to work. It has to do what it's supposed to do, and it has to have the right cost. If it doesn't really work or it's too expensive, no one will use it, and we don't solve any problems. So for a technology to be green chemistry, it has to work better, cost better, and oh, by the way, be better for human health and the environment. And so if you accept that definition, better performance, better cost, oh, by the way, better for human health and environment, the only real barrier is the invention. We have to ask ourselves, do we have the skill sets to invent? And that's what's so amazing about Austria, recognizing this and creating programs to be teaching green chemistry. This is, in my opinion, one of the most critical things we can do, because all the products and processes available today, I would argue only a very small minority are truly sustainable. If we do a good search and find something in a supply chain to improve the performance, maybe we'll be successful a little bit of the time. But right now, today, in 2022, the vast majority of technologies haven't been invented yet. This isn't a choice. If every human wanted to buy only sustainable products, if every store only wanted to sell sustainable products, if every manufacturer only wanted to manufacture, we got everybody's desire, we'd still be in trouble because we still have to invent a lot of these technologies. And you can't invent if you don't have the skills. Right? So this isn't the birth of ethics. This is really important. People who don't do green chemistry, it's not like they don't care, but for the first 100 or so years of industrial chemistry, what we did, we accepted that chemistry had to be toxic. It's just part of the way the world is. Chemistry has to be dangerous. But it's okay because we wear gloves to protect our skin. We wear masks to protect our lungs. We wear goggles to protect our eyes. We install scrubbers and filters and smokestacks to protect the air, the land, the sea. So we accept hazardous material and we protect the world by controlling exposure. The thing is, risk has two components to it. The controlling exposure, the revolution that is green chemistry is saying in the last 15, 20 years, the field of mechanistic toxicology and environmental health sciences has advanced. So we now can look at a molecule and predict whether it might cause cancer. We can look and see if it might cause birth defects or be an endocrine disruptor. So as we're designing the molecules, we can build out the hazard at the molecular level and reduce the requirement of exposure. Interestingly enough, industry immediately understands this. Imagine you're a company and you have a hazardous product and a safe product. All the costs associated with a hazardous material, much more expensive to work with a hazardous material than a safe material. So of course, companies prefer to have it. But if their workforce isn't trained to invent it, what do? And so the key is to have programs emerge around the world, like in Austria, so that we can train people to do this. So when we hear about all the sustainability objectives and everything that people's doing, the field of chemistry is growing and growing and growing and growing. Anyone who says chemistry is a mature science is crazy. We're just on the very, very beginning of chemistry. And as chemistry grows, there's a lot of people trying to define what we would like to do. Some people call it sustainable chemistry. Some people call it safe chemistry. People call it circular chemistry, clean chemistry, regenerative chemistry. Green chemistry is not another one of these. It isn't a definition of what we want to do. Green chemistry is a research and development tool. It is what chemists do in the laboratory to achieve whichever one of these objectives you want. So green chemistry doesn't define a target for chemistry to hit. Green chemistry seeks to change chemistry so that the shape of chemistry, more things that we do, fit whatever definition of sustainability you prefer to embrace. And so to do this, we're going to need new eyes, new ideas, and new academic programs to change the shape of chemistry, and perhaps I say the color of chemistry to green. Okay, and so here we are now, it's 2022. There are factories in South America, factories in Asia, factories in Europe, factories in North America. There is the electronics industry, there's the pharmaceutical industry, the cosmetics industry, the textiles industry, and here we are desperately trying to find a way to make it all work, make it circular, make it sustainable, do all these things, but it gets frustrating at times. Because all of these things were invented 50, 60 years ago without any idea of trying to put this together. And so we can get really sad. We can get really disappointed and say, oh, this is impossible. But you know what? I am so optimistic. And I'm optimistic because of what's going on in Austria. But also, just look at this picture a little bit more. Look at each one of these pictures really, really close. Look at everything. There's actually something that they all have in common. There's something that if you look really close, everything on this slide has something in common: chemistry. And if we want a sustainable future, it's going to happen through the tools of chemistry. So I want to congratulate everybody on today's event and what's going to happen today. And I'm really, really glad to have been able to be a small part of this. So congratulations for what's going on. And I can't wait to visit one day and 3 Dimensions be there to visit each of you. So thank you very much for listening to me. Have a wonderful day.